Okay, first off, I'm trying this video again. It was way too long the first time, so it wouldn't even upload to YouTube. And if anybody has any suggestions, feel free to let me know. I'm using Whiteboard on Windows 10 and Game Board to do the recordings. But if you guys have better ideas, feel free to let me know. I've never done this before. So today, or in this video, I'm going to talk about ionization energy. And if we think about that term ionization, we're forming an ion. But it's not any ion. It's specifically the energy required to remove an electron from a gaseous atom. Okay, so two keys. We're removing an electron, and it has to be a gaseous atom. The whole gaseous atom thing won't come up today, but later on it will be very, very important. Okay. So if we draw just a simple reaction, if we have a sodium atom, and it has to be in the gaseous state again, which is not normal for a sodium atom because sodium is a metal. But if it loses an electron, and it's still gaseous, we have that electron there. That is the equation for the ionization energy. And then we would have some energy associated with that, which we would call the ionization energy. And I don't know what it is for this, but it's some value in kilojoules per mole. And that is kilojoules. That's a K there. Let me just fix that. Kilojoules per mole. Okay. And so we can really do that for any chemical. We could have chlorine, for instance, Cl gas, and we just remove an electron and we get Cl plus gas plus an electron. Now chlorine doesn't normally form a plus charge, but that's still the definition of ionization energy. Okay, so if we want to look at a periodic table, let me draw my terrible periodic table that you guys have all seen before. Okay, and there's our periodic table, and we want to talk about the general trend. Yeah, the general trend. So which way is ionization energy going to increase? In other words, what's more difficult to remove an electron from? So if you think about the left side here versus the right side over here, and we're ignoring noble gases. Noble gases don't really come into play. They don't react very much. So what's easier to remove an electron, the left or the right? Just think about that for a second. And if you said it's easier to remove an electron from the left side, you're right. So ionization energy increases as we go from left to right. In other words, it's easier to remove an electron from, say, a sodium atom over here than it is to remove an electron from a chlorine atom over here. If you think about that, that makes sense. Because if we look at the first column, these guys all form what charge? +1. Next column would be a +2. And then these guys form -1 charges, the halogens. So that just kind of makes sense. Okay, now if we look top to bottom, what's easier to remove an electron from? The top or the bottom? Well, it turns out it's easier to remove an electron from the bottom. Now, why is that? Why is it easier to remove an electron from an atom down here on the bottom versus up here on the top? Well, the electrons on the bottom part of the periodic table are further from the nucleus than they would be on the top. Say a francium down here versus lithium up here. Okay, lithium is a small atom. It holds its electrons close to the nucleus in that 2s orbital. Down here, we're in the 7s orbital. Okay, those are really far from the nucleus, so the hold on those electrons is not nearly as tight. Okay, that is the general trend for ionization energy. One more thing while we're on it. Let's talk about what else increases along with ionization energy and helps to explain that trend. What increases from left to right? If you remember back, it is Z effective. Z effective increases as we go from left to right, and that's just the hold on those electrons due to an increasing number of protons as we go from left to right with the same the same core electrons. Okay, so just don't forget about that Z effective because it explains a lot of these periodic trends. And that's all for now. In the next video, I'll be talking about exceptions to ionization energy, or the general trend of ionization energy.